All right, guys, hopefully you can see this. Hopefully everything's going. Today I want to, just like I did last time, it's going to be a short lecture. I want to go through this even more hardy-Weinberg problems that you guys have hopefully completed and posted. And I want to bring it back out, so you need to actually pull it up, okay? And I want to go through it with you so that we are all understanding kind of what's going on here. Just like we did last time, we'll have probably just one more worksheet for you guys. I don't know how much we're going to get through this year. It's, this year's crazy. And I'm not seeing you guys as much. I'm not posting a whole lot every time I see you. If I saw you every day, I wouldn't have a concern about this. But because I'm not seeing you guys every day, I don't know if we're going to finish what I normally finish throughout the year. But, circumstances being as they are, that doesn't necessarily upset me. It's not ideal by any means, but it's understandable. So we're going to try still to get as much done as we can, and we're going to try to finish up hardy-Weinberg maybe today, maybe the next time I talk to you guys. I might throw a little quiz up your way just to kind of see how you're doing. Like I said, I may have said this last time, there were a couple people that have reached out to me and said, hey, they're having trouble understanding this. But after I have made it clear, at least on these lectures, that if you're having issues, we need to set up a one-on-one. We need to set up a Zoom meeting, because I think that's the only thing that's really going to, that I can offer, really. I mean, I can't, other than these videos and watching these videos and working the problems with me, if you're not doing that, you're not going to get this. Okay, I'm just going to be very blunt. You should be working every one of these problems with me, trying to comprehend it as we go. That's how you learn this stuff, guys. It really is. There's a reason that in your math classes that you go through these problems, that you go through the problems together. That's what we're doing here. But if you're still having trouble after you watch these last two videos a couple times, you're still kind of questioning your sanity a little bit when it comes to hardy-Weinberg problems, you need to get a hold of me and you need to say, hey, I would like a Zoom meeting so that we can go over the last set of problems that we did. Because I watched your video and I still don't get it. Okay? I'm not going to look at you and say, oh, no, sorry, too busy. It might be in the afternoon, don't get me wrong. It probably won't be in the morning when I'm kind of putting the day together and everything. But in the afternoon, we will set up a time, and we will meet, and we will go through these one-on-one. If you don't want to do that, if that just seems too awkward to you, and that's okay, I get it, then what I would suggest is watching these videos back a couple times and going through these problems a couple times. So let's go ahead. Let's not delay anymore. Let's look at this. Let's pray real fast. Lord God, bless this group. Bless those who are watching. I pray, Lord, that everybody's watching to try and understand this, to comprehend it. Be with them. In Jesus' name I pray. Amen. All right, so it says the frequency of two alleles in a gene pool. Oh, okay. It says the magic words right here. First off, before we even start reading, we should obviously write down our equations. So up here, I'm going to say p squared plus 2pq plus q squared equals 1. And then I'm going to use, this is my genotype equation. So if they're talking about an individual or a person from a population or individuals from a population, this is what I'm going to go to. But if they're asking for allele frequency, I'm going to say p plus q equals 1. Let's see if I can make that a little better. So this one, it says the magic word. It says the frequency of two alleles, which is just another way of saying allele frequency in a gene pool is for the dominant 0.19. So which one of these means dominant allele? That is P equals 0.19. Okay, and 0.81 for the lowercase or the recessive. So Q equals 0.81. Assume that the population is at hardy-Weinberg equilibrium. So it hasn't even asked a question, but it gave us P and Q, so I am perfectly happy. I know that no matter what A and B say, I'm going to be able to solve. So it says A, calculate the percentage of heterozygous individuals in the population. So it's looking for heterozygous individuals in the population. So we're going to be looking over here. Which one of these means heterozygous? Well, that's going to be 2pq. So all I got to do is plug it in. This equals 2 times P, which is 0.19, times Q, which is 0.81. Get out my handy-dandy calculator, which I happen to have right next to me here. And I'm going to say 2 times 0.19 times 0.81. And I get a 2PQ value of 0.3078. We're just going to say 0.308, excuse me. It says calculate the percentage, however, so this is going to be changed to 30.8%. How did I do that? I multiplied 0.308 by 100 to find percentage. Easy peasy. All right, letter B. It says, here, hold on, let's bring this up just a tad, shall we? Maybe. There we go. Okay, so I'm going to erase this one. If you guys, I realize that I'm moving things around already. I'm going to keep the P and Q because that, well, you know what, I'll leave it there, but let's just, B's going to be up here. Okay, let's erase this. Okay, it says calculate the percentage of homozygous recessives in the population. So which one of these is homozygous recessive? That's going to be Q squared. Again, you guys should be able to rattle those off. If I say, like if I just was testing you and I say, which one of these is the dominant allele frequency? You would say P. If I said, which one of these is the heterozygous individual? This would be 2PQ. Which one of these is the homozygous individual? That's Q squared. Which one of these is the homozygous recessive? Excuse me. Which one of these is the recessive allele frequency? That's going to be Q. Which one of these is the homozygous dominant individual? That's going to be P squared. You should be able to do that very readily. All right, so let's calculate the percentage of homozygous recessive individuals. So that's Q squared. So if I know Q is 0.81, I'm going to take 0.81 and I'm going to square it. Okay, because it's not just Q, it's Q squared. So you got to square that. So Q squared equals 0.81 times 0.81. 0.656. So let's calculate the percentage. So I'm going to change this to 65.6%. All right, so there's the first question. There's the second question. Fairly simple, fairly straightforward. Again, they gave you all the information that you needed with the very beginning sort of introduction to that question. All right. Number 2, this one's kind of long, there's 4 of them. An allele, capital W, for white wool is dominant over the allele lowercase w for black wool. In a sample of 900 sheep, 891 are white. And only 9 are black. Okay, now to be black, realize, because that's the recessive, you have to be lowercase, it's hard to show lowercase w, lowercase w. So, calculate the allelic frequency within this population, assuming the population is in hardy-Weinberg equilibrium. So, it wants to know what P and Q are because it's asking for allele frequencies. So, how do I find P or Q? Well, here it's given me, this one's a different one. It's kind of unique. It's given me numbers of the population. But because I know the exact count of individuals that are homozygous recessive and the exact count of individuals that are either P squared or 2PQ, heterozygous or homozygous dominant, then I should be able to figure it out because I also know the exact count of just individuals within the population. So 9 out of 900 of them, which I think is 0.1%, 9 divided by 100, hold on. Yeah, so, now it's not 0.1, I'm sorry, it's 0.09. Are lowercase w. So they are black. That is the phenotype that they're showing with the genotype of WW, lowercase w. So this is, believe it or not, the Q squared value. Okay. Now again, if you're sitting there going, okay, wait a minute, how do you get that? It's talking about individuals. So in the sample of 900 sheep, 9 of them, 9 people in that population. Or not people, rather sheep, have black wool. So 9 of them are black. If you take 9 divided by 900, you get 0.09. Okay, go ahead and do it with me. Make sure that that's right. 9 divided by 900, you get 0.0. What did I say? 0.09. 0.01. I'm sorry. That's why you should always check your work. Okay, I'm glad I did it again. 9 divided by 900. Let's do it one more time. 0.01. Okay, so my mistake there. 0.01 is the number of individuals. It's the Q squared value. It's the number of individuals with the lowercase w genotype, with the phenotype of black. Okay, so Q squared equals 0.01. Now, from that, I should be able to find anything that they ask. So it says calculate the allelic frequencies. Well, if they want to know P and Q, then I need to get Q by itself. So to do that, I take the square root, but whatever I do to this side, I have to do that side. So I get Q all by itself. Then I have to take the square root of 0.01, which is 0.1. Okay, do that in your calculator, make sure you get that. If Q is 0.1, then what do you think P is? Well, remember, P plus Q equals 1, so if I take 1 minus 0.1, I'm going to get 0.9 for P. There's my allelic frequencies. Number 1 is done. All right. That's all it asks. It only asks one question. Okay, so we go on to number 3. That was the answer for number 2. Hopefully you guys are good with that. All right, I'm going to erase this one. So hopefully you guys are good. Go back and look at it again if you need to. Number 3, it says in a population that is in hardy-Weinberg equilibrium, the frequency of the recessive homozygous genotype for a certain trait is 0.09, which is close to what we just said. That's where I got that 0.09. I must have looked down and saw that. All right, so this is the frequency of the recessive homozygous genotype. Which one of these is recessive homozygous genotype? That's going to be Q squared, okay, because it's homozygous and it's recessive. Q squared equals then 0.09, okay? That's what it gave us. Calculate the percent of individuals that are homozygous for the dominant allele. So which one of these means homozygous dominant? Obviously, it's going to be P squared. So this is what we're trying to find. We're trying to find P squared. We don't know what it is. But if we know Q, can we find P? Of course we can. Okay, so we need to get Q by itself so we can find Q. So we take the square root of Q squared to get Q equals, I don't know what the square root of 0.09 is, so hold on. 0.09 square root, that's 0.3, 0.3. So if Q is 0.3, we take it from 1, and P is going to be 0.7. Okay, I always have some students that get kind of confused by that. All I'm doing is subtracting a 1 minus 0.3, and I get 0.7. Because P and Q have to add up to 1. Thank you to that equation. So now I know P and Q. I'm happy. I'm good. All I'm looking for is P squared, so I need to take P squared equals 0.7 squared. P squared equals, what's 0.7 squared? I'm not sure. 0.7 squared, we get 0.49. All right, so there's my P squared. Put a box around it, make it happy. We're good. Answers that question. All right, last one. It's kind of down here low. I can't move it up for whatever reason. It says in a population that is in hardy-Weinberg equilibrium, 38% of the individuals are recessive homozygotes. Okay, so which one of these means recessive homozygote? Recessive homozygote is right here, Q squared. So that means Q squared equals 38% or 0.38 if you want to make it into a decimal. All you got to do is divide it by 100 and you're there. For a certain trait. In the population of 14,500, calculate the percentage of homozygous dominant individuals and heterozygous individuals. All right, so real simple. They want homozygous dominant, which is P squared, and heterozygous, which is 2PQ. So this is just kind of asking for the whole shebang, if you will. I want to know both of those values. In order to find both those values, I have to find P and Q. So you basically have to find everything. To find Q, real simple. Okay, I want to get Q by itself. So I get rid of that square root. Whatever I do to that side, I have to do that side. Or I get rid of that square, rather, by taking the square root. So I'm going to get Q equals whatever the square root of 0.38 is. Not sure. 0.38. we get 0.6164414. So I'm just going to round that to 0.62. Okay, so that's my Q value. If I take 1 minus 0.62, I'm going to get my P value, which is 0.38. Now I can solve for P squared and 2PQ. So I take 0.38, I'm going to bring this down here. 0.38 squared is going to give me P squared. Hopefully you guys can see this. So I take that and I square it. 0.38 times 0.38. I get 0.14 repeating basically. So I'm just going to say 0.14. All right, so that's my first thing that they wanted. My 2PQ is going to be 2 times P, which is 0.38, times Q, which is 0.62. Okay, ow. Ooh, that hurt. 2 times 0.38 times 0.62, we get 0.47. And 4712, but I'm just going to round 0.47. That's my 2PQ. All right, that's it. They could have asked you like what, so that's actually 47%. They could have asked you how many people or how many individuals were heterozygous or homozygous dominant, whatever. And you could have actually solved for that as well, but they did not ask that. So I'm going to leave it there. That's how to do these problems, guys. Fairly, I wouldn't say simple, but straightforward. Oh, man, for a second there, I thought I wasn't recording. I was going to get really sad. So watch this video a couple times if you need to. Go back through, try to understand it. Hopefully it makes sense. I'm going to have another set of problems for you guys today. Try those after you go through this video. Okay, do not skip on this. I can see the views. I know some of you guys aren't watching this. Listen, don't come to me. This isn't like a warning or anything. This is just truth, guys. If you look at this, if you haven't watched the videos, don't come to me and say you don't understand how to do this. Because the only difference between right now and what we would be doing in class right now, if I had you in class, is you guys would be sitting here and you'd be forced to watch me do this stuff. Okay? So please act like this is class. This is only a 17-minute video. I think the last one was only 15 minutes. Act like you're in class and put the work in, put the effort in, and try to understand this. I know for some this is challenging, but if you try, I promise, this is the same thing. I wouldn't be doing anything different. This is the same thing I'd be doing in class. Okay? The only difference is right now you got Fortnite or Call of Duty or whatever else staring you in the face. Okay? And you're a little bit more distracted. Okay, so I suggest you guys go to a quiet place and you focus and you really try to work these problems to try and understand it. Okay, text me, email me. You don't have my cell phone number. Email me or get a hold of me via Google Classroom if you're having trouble. Okay, don't just let it go. But I will talk to you guys next time. We'll go through probably the last set of problems and then we'll take a little quiz and we'll be done with this. Okay, so we're running out of time. If you don't understand this, we're running out of time to understand it. All right. Talk to you guys later.